Leopards are among Earth's most powerful and adaptable predators. They hunt in forests, grasslands, mountains, and even the edges of cities. Their muscular build, stealth, and night vision make them top-tier survivalists. But what happens when we remove their greatest necessity, oxygen? Could a leopard survive on an exoplanet with no oxygen at all? At first glance, the answer seems obvious: absolutely not. Leopards, like all mammals, rely on oxygen to stay alive. Every breath fuels their muscles, powers their brains, and keeps cells functioning. Without oxygen, their hearts stop, their blood turns acidic, and death follows. But in science fiction, and increasingly, in science, extreme survival is being reimagined. So let's ask the question again, but this time with science in mind. There are exoplanets beyond our solar system with strange, hostile atmospheres. Some are covered in methane clouds. Others are blanketed in carbon dioxide or bathed in toxic radiation. And many, possibly most, have no breathable oxygen whatsoever. But these exoplanets also raise a question that has fascinated scientists for decades. What if life could evolve without oxygen? On Earth, oxygen only became abundant about 2.5 billion years ago. Before that, life existed in forms we now call anaerobic, life without air. These early organisms used sulfur, methane, or iron as energy sources. And some of their descendants still survive today in deep-sea vents and caves. They thrive in toxic sludge, hydrothermal plumes, and the guts of animals. So nature already shows us that life can survive without oxygen. But leopards are not microbes. They are oxygen-dependent mammals built for fast bursts of energy. Without oxygen, their mitochondria, tiny cell power stations, can't make ATP. No ATP, no energy. No energy, no movement, no heartbeat, no brain function. So how could a leopard survive on a world with no oxygen? Option 1. Genetic redesign. Scientists could theoretically engineer a leopard to metabolize another gas. Perhaps sulfur, hydrogen, or ammonia, like some anaerobic bacteria do on Earth. But this would require rewriting how nearly every organ and cell functions. The lungs would need to absorb something entirely different from air. The blood would require a new molecule to carry chemical energy. Hemoglobin would be obsolete. The brain would need to tolerate low energy processing and extreme metabolic stress. In short, this version of the leopard would be a completely new species. It would not be the leopard we know, it would be a post-oxygen predator. Option 2, technological survival. A leopard could be sustained inside a high-tech suit or sealed biome. Imagine a dome filled with oxygen on an alien landscape. The leopard hunts within this controlled bubble, limited to artificial zones. This method wouldn't change biology, but would demand constant maintenance. If the oxygen bubble fails, so does the leopard. This isn't adaptation, it's captivity under extreme conditions. Option 3, cyborg augmentation. Futurists imagine a time when biology merges with machines. Could a leopard be fitted with internal oxygen processors or metabolic converters? Implants that turn alien gases into usable fuel, bypassing organic limits? Science fiction? Yes. But so were satellites, artificial hearts, and lab-grown meat once. There's also a fourth option, exoplanets that produce oxygen naturally. Not every alien world is hostile to air-breathing life. Some exoplanets may have oxygen atmospheres created by alien plants or chemistry. If such a world existed, it might host leopards without any modification. But even then, other factors matter: gravity, temperature, pressure, and radiation. Would their bodies collapse under intense gravity, or float away in weak gravity? Would their paws freeze in liquid nitrogen lakes or burn on acidic soil? Would solar radiation mutate their DNA faster than they could reproduce? To survive on an oxygenless exoplanet, leopards would need more than air. They'd need immunity to toxins, heat resistance, pressure adaptation, and sensory overhauls. Their eyes might evolve to see in different light spectrums, infrared or ultraviolet. Their skin might develop insulation against chemical burns or sub-zero winds. They might lose their spots, or evolve new ones for alien camouflage. The truth is, a leopard cannot survive on an exoplanet with no oxygen, today. Its body, metabolism, and evolutionary design are too closely tied to Earth. But the future opens doors biology alone could never imagine. With gene editing, bioengineering, and synthetic evolution, survival might be possible. Not for Earth's leopard, but for a distant cousin, built for a new world. A creature inspired by Earth's predator, reborn in an alien ecosystem. So could leopards survive on an exoplanet without oxygen? Not as they are, but perhaps as they could become. Because where science and imagination meet, even the impossible starts to breathe.